space is terrifyingly deadly. But is it so deadly that we're trapped in our solar system forever? Could it be that the reason we've never met aliens is because interstellar travel is just too difficult, even for the most advanced civilizations? Some scientists think so. But is that really the case? Or is there still hope for humanity to one day touch the stars? Ever since physicist Enrico Fermi asked, "Where is everybody?" we've been puzzled by the lack of alien civilizations. If the universe is filled with billions of planets that have existed for billions of years, why haven't we seen evidence of anyone else? There are many possible answers. Maybe we're among the first intelligent species to emerge. Maybe advanced civilizations inevitably self-destruct. Or maybe they're out there, but they've never left their home planets. Not because they didn't want to, but because space itself won't let them. To answer that, we need to understand what makes interstellar travel so hard. And no, it's not just about the insane distances. Let's start with the obvious problem: distance. The closest star, Proxima Centauri, is 4.2 light years away. Even the fastest spacecraft we've ever built, the Parker Solar Probe, moving at a blistering 163 kilometers per second, would take over 7,000 years to reach it. But here's the thing. Distance alone isn't an unsolvable problem. Projects like Breakthrough Starshot propose using solar sails powered by giant Earth-based lasers to propel tiny spacecraft to 20% the speed of light. And while these crafts are just small computer chips, future advancements in propulsion, like fusion drives or even antimatter engines, could, in theory, allow larger ships to reach relativistic speeds. So, problem solved? Not quite, because there's an even bigger threat lurking in deep space, one that could make interstellar travel outright impossible. Meet our real enemy, the interstellar medium. Sounds fancy, but it's basically all the dust and gas floating in deep space. It's thin, but when you're moving at 20% the speed of light, even a single dust grain becomes a high-velocity bullet. At those speeds, a tiny dust particle, just a millimeter wide, carries enough energy to vaporize an entire spacecraft on impact. And then there's the radiation. At relativistic speeds, normal hydrogen atoms in space become deadly cosmic rays. Without proper shielding, astronauts would be exposed to radiation levels comparable to a nuclear reactor's core. Translation: a one-way ticket to being fried alive. So, does this mean the dream of interstellar travel is dead? Not necessarily. To survive, a starship would need a shield, not just against dust, but against radiation. A thin titanium plate, a few centimeters of lead, or even a meter-thick water layer could block most of the deadly rays. But the more shielding we add, the heavier the ship gets, and the harder it becomes to accelerate to high speeds. So the real question is, can we find the right balance? Can we build a ship strong enough to survive, but light enough to travel fast? The good news? Yes. Studies show that a well-designed spacecraft could make the journey to Proxima Centauri. The bad news? It's going to take extreme engineering, technological breakthroughs, and probably a few unfortunate test runs before we get it right. But here's what we do know. Interstellar travel is hard, but not impossible. Space is deadly, but not deadly enough to stop us forever. And if there's one thing history has taught us, it's that humanity refuses to stay in one place for long. So maybe, just maybe, the answer to Fermi's question isn't that everyone stayed home. Maybe they just haven't arrived yet. If you found this video fascinating? Let us know in the comments. Do you think we'll ever reach another star? And if you want more mind-blowing answers to the universe's biggest questions, hit that subscribe button and turn on notifications. Because here at Beyond the W's, we go beyond the what and dive straight into the why.